Betsy receives a flower in a vase, and the vase is shaped like a rectangular pyramid. So she wants to know the volume of the vase so she can put her water in it perfectly and not have an extra drop. Is that realistic or what? No? Not so? Nobody cares? Okay, cool. She measures the height, the length, the width of the vase. The vase measures 12 inches tall, 3 inches long, and 2 inches wide. What is the volume of the vase? So it's a rectangular pyramid. So if we're finding the area of the base, what would the area of the base be? Length times width, so it would be 3 by 2. Okay, so the base is 6. And then if this is a pyramid, should we use 1/3 or not use 1/3? We're going to use the 1/3 because it tapers in as it goes up. Okay, so we're going to use the 1/3, and we're going to use the base, and we're going to use the height. So 1/3 times 6 times 12, 24. Have you guys memorized the formulas yet? We've used them a lot. These formulas on the board. This shape was a rectangular pyramid. I am not convinced. That was not convincing. That looked like your lying face.
It's like it's 1/3 times this times pi.
Mm-hmm.
But it's definitely not because I just.
Yeah.
I knew there was a fraction of that. That's not okay.
All right.
It's not 3 sides of a pyramid.
Okay. The next problem. At the store, Jason finds the total volume of soda in a pack is 381.51 cubic inches. Have any of you guys ever gone to the store and you just real quick calculated the volume of soda in a package? Yeah, me either. Yeah. Okay, so we're saying this is not a reasonable math problem. Okay, maybe some of the details will be reasonable. If the cylinder-shaped can, okay, that's reasonable. Cans are cylinders, right? We agree with that? We agree? Yeah, okay. The cylinder-shaped can has a height of 6 inches. It's a little bit of a reach. That's a pretty tall can. 6-inch can. That's not a normal can.
That's like 24 ounce.
That's like a big can. Okay, we're okay. Okay. We're gonna stop. We're gonna stop while we're ahead. Okay, and it has a diameter of 3 inches. Okay. Oh, and do we like that they gave us the diameter? No. What do we want instead? Radius. Okay, so we're gonna say radius is. What's the radius? 1.5. I'm just gonna choose 3. I'll just okay. And then they want us to take that information and determine how many cans are in the pack. Okay. So let's go ahead and figure out the volume of just one can. Now, this problem does my own personal pet peeve where it says use pi equals 3.14. You could. Why don't they let us use the pi button? They're stupid. They're like, these people can't handle rounding. Let's simplify this problem for them. Okay, so the area of the base of a cylinder is what? Pi r squared. So we're going to use pi times r squared. So instead of writing pi, I wrote 3.14 because they made us. Rude. Okay. We do what we want. We're strong, independent women and men. We should. And our rebellion is we use the pi button. All right. And so when we type this in, what do we get? Okay, 7.065. Okay, so the area of the base is 7.065. And then to find the volume of the cylinder, do we need a 1/3 for a cylinder? No, how do we know? It does not taper in, it goes straight up and down. So it's no 1/3, it's just area of the base times the height. So the area of the base times a height of what? 6. Okay, so that times 6. And what do we get? 42.39, perfect. Okay. So if we know the volume of the entire pack and we know the volume of one can, how could we use that to figure out how many cans we have? Yes. Okay, so we're going to say total volume divided by volume of one can, and that's going to give us the number of cans. So I'm writing this down on my notes so that if I ever do a similar problem, I have something to look back on, just in case I have a brain fart later or I need something to kind of like spell it out for me or whatever. So the total volume was 381.51. The volume of one can was 42.39. And when I divide those, what do I get? It's 9, and you don't even have to round it. That's why they made us use 3.14. They were like, these kids aren't capable of rounding. We could have used the pi button. I take it personally too.
What I say we protest against the 9 cans and say add one more can.
We want a 10-pack.
Yeah.
But in a 10-pack, that's not even square. You want just like a little weird lump?
Because then you can put it on your card. Then you can put it on your card.
So you have a square with a lump space?
You can make a rectangle.
Oh, 10, because then 2 by 5. I got you. I was picturing it would be 3 by 3 with like a lump somewhere. That's 2 by 5. I got you. I got you. Okay. The pack holds 9 cans. I'm going to tell your guys' English teachers that you get mad in math when we have to write one sentence. One sentence. Now put your pencils down and do a little stretch, stretch, stretch. Just stretch those fingers out. Stretch, 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 stretchy, stretch. I should get you guys little like exercise balls for your hands, little like finger weights, so you could be like, work them out, work them out. And then every day that we had to write sentences, I'd put the little weight workout stations on your desk so you would know we got to do some finger weightlifting because we got to write sentences today. No? Not a good idea? Okay, let's move on. All right, you guys, this next one is some marketing magic. They have a store called Gobs of Globes. Money making, we think? No? Okay. It's a specialty store that carries a lot of globe-related products. One is a globe piggy bank. I don't know what that means. The world is a pig, or are we just saying globe as in circular? A pig with a circular body instead of a ovally body? I don't know. The standard globe piggy bank that they carry has a volume of 500 pi thirds cubic inches. A customer asked for a custom-made version with a radius that is quadruple the size of the standard one. That's right, folks, it wasn't large enough. Based on this information, what will the radius of the custom-made version be? And they were like, they looked at it and they said, that piggy bank ain't big enough, I need a bigger pig. Okay, so what's the shape of a globe? A sphere. Okay, what's the formula for the volume of a sphere? Okay, 4/3 pi r cubed. Okay, and so that is going to equal what? 500 pi thirds. Okay. And so could we take this and figure out what the radius of the regular piggy bank globe is? Yes. Okay, how do we do that? Yes.
I would go with you take the answer that equals this over 3.
Mm-hmm. Is there something we could cancel first, do you think?
The pies.
The pies. Let's get rid of the pies. That would feel a little bit more comfortable. What do you guys think we should do next? Yeah, times both sides by 3/4, which is the... What is 3/4? Wait. What is 3/4? What's its name in this problem? Starts with an R. Reciprocal. It's the reciprocal. So we're multiplying by the reciprocal to get rid of the 4/3. You could just multiply by 3, but you'd still have to get rid of the 4, right? So you're right. It would get rid of that and make that just the 500. So now we have 500 divided by 4. What's 500 divided by 4? 125. Does anyone know what number multiplied by itself 3 times is 525? Or is 125? It's 5. So we had to do cube root, we get the radius is 5. So if the regular radius is 5, then what's the quadruple radius? 20, okay. So the custom-made piggy bank has a radius of 20 inches. That is wild. That is a really big piggy bank. Are you guys picturing that? 20 inches? That's like, that's more than 1.5 feet. That's just the radius, so that means the diameter is more than 3 feet. They must have a large house. Yeah, the richest woman. The richest person in the world is a woman.
Anyway, very large piggy bank in their house that holds all of their money.
They just have a room dedicated.
It's just a piggy bank that holds all of their money. Yeah, a white room with nothing else but just a piggy bank. When you walk in,
Why's it gotta be white?
Okay, I just saying any colored room that's
there we go.
Color.
Don't worry, guys, it's off-white. We've moved on. Okay. It's 2022. We're getting better at this. Yeah. It's fine. It's been corrected. It's been corrected. All right, next problem. Gage thought that was very funny. Yeah. I've been working on my jokes. All right. At work, Kevin is designing a product prototype. Part of the product is a cylinder with a volume of 108 pi cubic inches and a radius of 3 inches. We don't know what the cylinder is, but that's what the size is. When he presents the prototype to the company, they're like, nah, man, the volume should be 171 pi cubic inches. Okay. So based on that information, how much height does he have to add? Okay. What are they saying? What are they not saying has to change? What was not mentioned changing? The radius. So since they did not say the radius has to change, we're going to assume that it's the same. Okay? What 3D shape are we working with? Cylinder. Okay, so we're going to say we've got the old cylinder and we've got the new cylinder. And we always start off with the base. And how do we find the area of the base of a cylinder? Pi r squared. What's the radius for both cylinders, the old and the new? 3. Okay, so we're going to say pi times 3 squared, which is 9 pi, and that's the same for the old and the new. Okay, so now let's find the volume. Based on this information, we're not going to put our volume in yet, even though we know what it is. So based on this information, we would say the area of the base, which is 9 pi, multiplied by what? The height, which we don't know. So we're just going to put h for the height that we don't know. So we're going to say 9 pi times the height, which we don't know. But we do know what the answer is. So what's the answer for the old? Don't tell me the answer yet. Don't tell me the answer for h, but what's the answer for the volume? 108 pi. And then what's the answer for the volume for the new? 171 pi. Okay, so now we say 9 pi times h equals 108 pi. 9 pi times h equals 171 pi. Are we comfortable with how I set those up? That's okay? Make sense? Okay, so what's a good first step when we solve these equations? Yeah, cancel out the pi. It looks confusing. Oops, I missed the pi right there. Cancel out the pi's. Make these equations look a little bit less scary. Okay, and then Bree, you want to tell me how to finish this one?
Oh, yes, I would love to.
I don't think she knows the answer yet, but I think she can probably.
I have already got it.
I know you do. Okay, I was joking.
Okay, when you divide both sides by 9.
Uh-huh. Marvelous.
So you do it on the other side.
Okay.
And that's going to equal 19.
Okay.
And then subtract 12 from 19.
Yeah. Perfect. And so they went between these two. The old one was 12. The new one was 19. And so they went up by 7 in between. Was that math? That was math poetry? Is that what you just said? My heart just got all warm fuzzy. That was beautiful. All right, so the answer is B. Well, this one doesn't need a sentence because it's a multiple choice problem. I appreciate it. It's good. Okay, we'll write a sentence. How much height will he need to add to the original cylinder? Kevin.
I just wrote 7 inches.
Period?
No, 7 inches must be added to the original cylinder.
There you go. That's fine. know I can hear you.
I meant like Kevin, like
That's why you're turning red.
no, like Kevin's like a little in the piggy bank box for his house.
He didn't buy the piggy bank.
Yeah, but he could have. No, Kevin is the customer that bought the giant piggy bank.
Bless.